Hey there, welcome back. Today we are going to solve a CS50 problem set where we modify the volume of a wave audio file. This is a fun exercise that uses file manipulation and basic audio processing. So let's dive in and see how we can solve it step by step. In this problem, we are given a wave audio file and our task is to modify the volume. The volume is controlled by a scaling factor. The program needs to perform three steps. Step 1. Read a wave file that contains header information and audio data. Step 2. Adjust the audio data based on a factor. For example, double the volume or reduce it. Step 3. Output a new wave file with the modified audio. Let's break down how to approach the solution step by step. Now, let's break down the code we've written to solve this problem. We start by checking the number of arguments passed to the program. The correct usage is input file, input.wave, output file, output.wave, the scaling factor for volume. Step 2. Opening files. We open the input file in read binary mode and the output file in write binary mode. This is because we are working with raw binary data, not text. Step 3. Copying the header. This is our main step in this problem set. Okay, so at the beginning of any wave file, there's something called a header. This header contains important information about the file, like its format, length, and other details. We don't want to change the header, we just want to change the audio part. Here's what we do. We declare an array called header, which will store the first 44 bytes, the header part of the .wave file. Byte is defined as uint 8t, which represents a byte of data, 8 bits. The constant header size equals 44 is used because the header of a .wave file is 44 bytes long. If I read header, command space of comma space byte, comma comma, header size comma, and then input semicolon. Fread is a function that reads data from the input file. We tell fread to read 44 bytes, the size of the header, from the input file and store it in the header array. Size of byte tells the program the size of each item it's reading, 1 byte in this case. fwrite header, size of byte. Header, size, output. fwrite is used to write the data we just read, the header, to the output file. Just like in fread, we specify the size and number of bytes we want to write. This ensures that the header of the input file is preserved and written unchanged to the output file. Now let's move to step 4, which is modifying the audio data. Now we get to the audio data itself. Audio is made up of tiny pieces called samples. Each sample is a number that represents a sound. These numbers are stored as 16-bit values called int16t. Here's what happens. int16t buffer. int16t is a type that represents a 16-bit integer. Each audio sample is stored as a 16-bit number, so we use this type to handle the audio data. While fwrite address of buffer, size of int16t, 1 input of fread, reads one sample from the input file at a time and stores it in the buffer. Size of int16t ensures that the size of the sample is correct, 2 bytes because each sample is 16 bits. The while loop continues reading samples until the entire audio file has been processed. Buffer multiply equals factor. This line multiplies the sample value, buffer, by the factor that we received from the user. This adjusts the volume. If the factor is greater than 1, the volume increases. If it's less than 1, the volume decreases. fwrite, address of buffer, size of int16t, 1, output. This line writes the modified sample, buffer, back to the output file. Again, it specifies the size of the sample and the number of samples to write. In this case, just one sample at a time. Step 5. Closing the files. Finally, we close the filers to ensure that all data is saved and memory is freed. We've successfully solved the CS50 problem and modified the volume of a WAV file. If this video helped you out, don't forget to like, subscribe, and hit the bell icon so you don't miss more CS50 solutions and programming tutorials. Drop your questions in the comments and I'll be happy to answer them. See you next time.